Hi, I'm Wolf McNally for Blockchain Commons. In this short demonstration, I'm going to show you how you can use crypto requests and responses to request a public key and then use that public key to generate a partially signed Bitcoin transaction that is then sent back to Gordian Seed Tool for signing. As you can see, I have a number of seeds on my device here. Let's assume that the creator of a PSBT wants to request that I co-sign a transaction. He'll need a public key, the private key of which will be used to sign the transaction later. In this example, I have a crypto request called the cosigner derivation request, which requests that Seed Tool send along a XPUB or a public HD key of the Seed Tool user's choice. You could also create a request for a specific key, but in this case, we'll assume that the transaction creator doesn't know what seed will be used. I can read that crypto request by telling Seed Tool to go to scan mode to scan the QR code. As you can see, the QR code contains a key request. It says, another device is requesting a public key from this device with this derivation. It's on testnet. It's a cosigner derivation. Because the specific fingerprint of the seed wasn't specified, it asks us to select a seed. We choose Alice. So now it's displaying the HD key derived from the seed called Alice. It says, sending this public key will allow the other device to verify but not sign transactions with it. Of course, it will also allow it to create PSBTs with it. Once we approve this, Seed Tool generates a crypto response containing the crypto HD key. This is sent out, completing the request response cycle by providing the requester with a public key that they can use in their PSBT. Next, we will receive a PSBT signer request. It will be for a multi-sig, one of two, one of the cosigners being the actual private key corresponding to Alice. In Seed Tool, we tell it to scan this PSBT signature request, and it says, if you approve, this device will sign one input on the transaction using keys derived from one seed on the device. But it points out that when signed, this transaction will still require one or more additional signatures. It gives you a summary. You can see the amount of the total inputs, the amount that we sent, the transaction fee, and the amount that will be returned as change. Because the PSBT doesn't dictate whether it's a mainnet or testnet transaction, you can decide whether to display the addresses in the transaction as mainnet or testnet addresses. You can see that it contains one input, and this input will need to be signed by the key derived from Alice. The fingerprint of the key is displayed, which means that Gordian Seed Tool has recognized that it has the seed that can generate the key to sign this input. It doesn't know anything about the other cosigner required on this, but once this is signed, it will be sent back so the other cosigner can sign it to have a completely finalized transaction. It also points out that the output from this will eventually be signed by Alice as well. That's also a multi-sig output. That's for the change. And then it points out that it's 0.00001 Bitcoins and the address that it's being sent to. So once you approve this, you can see the crypto response containing the updated PSBT. If this crypto response were a little bit bigger, this QR code would actually animate using UR's ability to create streaming QR codes using fountain codes. But for this smaller PSBT, we're ready to go with a static QR.